welcome to our Johannesburg Group 37 Brownfields presentation. In this presentation, I'll be with my colleagues, which are Akani Novella, Gift Petzileballo. We are first going to start by our Brownfields background. Our goal is to enhance and extend the robot world code base by implementing new functionality and refining existing features. Our focus will be on leveraging our understanding of OOP principles to deliver a high quality, maintainable code base. By collaborating on this project, we will successfully ability to manage code base evolution. Effective efforts will ensure that we deliver a robust and well-maintained system. Now moving on to section A, which is managing software development source files. Our first slide is about identifying source files and meeting specifications. So when our Brownfields module started, we had specific specifications that we were supposed to follow and meet the requirements fully of. This is a full flowchart of how we were able to ensure that our files meet the project specification and requirements, and also to make sure that we are managing versions of both main and additional files. So in the flowchart, you can see that we started the project. We then identified essential source files. We identified additional dependencies like external libraries and config files. We checked against project specifications, initialized version control, created repositories, added files, and committed our initial version. We then started with the ongoing development by refactoring and adding new code. We made changes to the code, committed the new versions, and made sure that we have up-to-date branches. When all of that was done, that's when we completed our Brownfields project. Version management and retrieval. So we used the Git, and this is just the screenshot there just shows you our main branch with all of our files that we have committed and just pushed into our version control tool. So this is an example of using version control tools. So this shows you what happens in a Git merge conflict and how to fix it. So you will firstly start by committing, and then you will get an error stating that there's a Git conflict. You will then add a command where you say git merge, and you then say to which branch are you trying to merge to. It will then tell you that there's a git conflict or a merge conflict in whatever file that you are trying to merge into. It will tell you that to fix your conflict and then commit the result, you will need to then use the git conflict help command, and then you can commit your result. Once all of that is done, you do the git status, which will show you if your branch is up to date and if there is anything that you still need to fix. If everything works fine, then you will then continue to git add, git commit, and then push whatever work that you have done. I will then be moving on. I will then be moving on to section B, which will be covered by JHB37.
Section B, Code and Design Alignment. We start with the main method, which basically just prompts the user for a name so that they can connect to the server. Socket is created, a new robot client is created where the socket and the name entered is used as arguments to the constructor. And then the new robot client runs a thread that listens for the messages and another function that handles all the commands. Um, the handle command basically just gets command from the command line and then proceeds to then call the create requests function. And the create request function is the one that creates the command, checks whether the inputted values are correct or not. And it uses the request classes to then create requests that are then sent to the server. This is an example of how a launch request is created, a movement request, and a general request. Now, once a request is generated, we have a class called robot server, which is basically going to act as a buffer between the server, the world, and the client. It is going to be responsible for uh, taking back responses to the client so that the user can see the responses from the server. So what generally happens is that the request is read from the buffer and is passed, because since the request is a JSON file, it becomes a JSON node. That JSON node then gets printed out. So all the requests are going to be seen on the server, on the terminal. A command is going to get extracted and is going to be processed. The command class has a static function that takes in the command, the arguments from the command, and the current instance of the robot server. This is an example of the create command. It basically does all the business logic, checks whether the robot server has a launched robot, and if it does not have a launched robot, it then creates a response that tells you that you don't have a robot launched. If you try to input a command like state or moving forward, but you don't have a robot launched, it's going to give you a no launch command. And then otherwise, if you have a robot launched, you will then proceed to these commands, which will give you the state, look, etc., etc., etc. Now, our server has a world that is created. So just to go to the server, so what happens is when you run the server, it runs in the main method runs and the server starts. And what then happens is that this is the logic that listens for the sockets that are going to connect to the server. And then it's going to, every time a socket connects, it's going to create an instance of a robot server, which is basically the interface between the client and the server and handles all the business logic relating to the commands. A world is created, and what happens when a world is created is that the constructor is called and everything in the configuration file here, which can easily be altered to whatever you want it to be. It's going to be read into the world and it's going to be stored in the variables. You then have the types of obstacles. What the world then does is it creates a random number of obstacles, and then the type of obstacles that are created are also random. It then populates the world and obstacles exists. A variety of modes or statuses are required, and so we created an enumerated class which basically has all the types of statuses that a robot can have. It's either it's dead, it's repairing, or it's reloading. We also have the direction that is used, such as west, east, south, and north. This is the response class, and this class has all the functions that generate responses that are going to be sent back to the client for the user to be able to see. This is the position class that basically keeps track of the positions of the robots and the obstacles. This is the abstract obstacle class, which is the base class for all the obstacles that are there in the world. It implements this interface. This is a type of obstacle, which is a lake. And as you can see, it has a field that tells you whether or not it is bottomless or not. This is a mine, which is also a type of obstacle. This is a mountain. And these are the different commands. So this is, for example, the right command to turn right. This is the repair command, which uses a timer and only returns a response after a certain amount of time. During that time, you cannot issue any other command. Your robot can't move, and the robot server will not accept any commands from the client. This is just one example of the different types of commands that exist. This is our database. This is the function that creates the tables. And this is the function that inserts into the world. This is the function that inserts the obstacles into the database or our table. And this is what retrieves the names from the world, as you can see. Now I'm going to demonstrate how our server works in a live demonstration. So we have the multi-server that is running here, and we have the robot that is running here. So I will enter my username so I can connect to the server. Once the server is connected, it will send me a response that says I've successfully connected to the server. So now I will try to move forward, but I can't because I don't have a robot launched, as you can see in the error response. So I will then have to launch a robot. And the type of robot as well. It'll then give me a response from the server. Now in the server, I can see the state of the world. So I can do a dump that shows me the state of the world. As you can see, it shows me the robot that exists in the world. It then shows me the different types of obstacles in the world. I can choose to see only robots in the world. There we go. I can move forward. As you can see, I successfully move forward up the y-axis. I can look and see my surroundings. It'll then give me all the types of obstacles that are within my surroundings. So as for instance, this is the square obstacle to the south and a distance of 5 away from me. This is another square obstacle, which is a distance of 46. Now the visibility is set to 100, so it can see things 100 clicks away from it. This is another obstacle, as you can see, and it shows you all the obstacles that are within the range. So now I will launch another robot. We'll just name it Tim, and we'll launch. another type of robot. It is successfully launched. We can check the dump command that shows you what robots exist and also obstacles. There you can see we have a robot there that is launched. And please note that robots will never launch in the same place. So for example, we can launch another robot. We'll call it Ben. We'll launch another sniper. As you can see, then we can have a dump, show the robots in the world. As you can see, these are all the robots in the world. So now we can move Ben, turn him to the right, and turn right. As you can see, his direction has changed. For 3, as you can see, his location has changed as well. We can turn left, taking face up. As you can see, these are robots in the world and the locations. Then move them up 10 units, and we can then fire to see if we're going to hit a robot. Yes, as you can see, we fired and hit the robot that was in front of Ben, and because the sniper only has one shield, so this is the state of kill. As he got hit, he has no shields now, so if he gets shot again, he will die, so he probably needs to repair. So currently he can't do anything for the time being because he's currently repairing, and he will get a response showing that he has repaired. And he is done. He's in repair mode, and then now if you check the state, his shields are back up and he is now normal. So now Ben can reload. So he lost one shot. Ben can reload. Again, it takes time to reload. We're going to receive a response after successful reloading. As you can see, he's reloaded his shots. And so fire again. As you can see, he hit kill. And yeah, we are done. Our testing techniques involved using JUnit to write unit tests and acceptance tests for our server for different parts of the server, for instance, for creating our JSON requests, for creating our responses, etc., etc. We also created acceptance tests to test certain parts of our code which we thought were very important, like moving, like launching the states, and the database tests. So for example, this is how one of the tests would look like. When you run them, they will pass. This is, for instance, for moving forward. That would maybe be for the robot state, etc., etc., etc. And for our unit tests, we test sort of individual things. These are responses. We check how it creates the responses and if it returns the correct responses. This is to convert to JSON nodes, which is a very, very important part of our program. And this would be for instance, testing the socket and connectivity and testing our server. So yeah, that concludes our testing and
testing techniques?
I am Agani, and I will be covering data management. Now, when you're working for a company and you're in the software development team, you're gonna need to store the data of the company somewhere, somehow. And when we do this, and in the process of doing this, we come across problems. And there are solutions to these problems. Now, I will be discussing the problems and the solution. Data redundancy is one of the problems that occurs when storing data. This occurs when the same piece of data is stored in multiple places within a database. And that is a huge problem. You need to have a single piece of data. But the solution of this problem would be to centralize data storage. And this involves storing data in a single centralized location to avoid data redundancy and ensure that the pieces of data that are being stored are only stored once. The next problem we typically face is data inconsistency. Now, data inconsistency arises when different copies of the same data do not match. And the typical solution for this would be that we would implement data integrity constraints. And these are rules that are defined within a database that maintain the accuracy and consistency of data. This enforces constraints such as unique keys and foreign key relationships. The next problem we would face is concurrent access issues. Concurrent access issues occurs when multiple users or applications try to access and modify the same data simultaneously. And the solution for this would be to ensure, would implement transaction management. This ensures that data integrity is controlled and coordinating concurrent access to the database using the techniques like locks, transactions to manage simultaneous operations. The next issue is data security concerns. Now, security concerns involves unauthorized access, data branches, and data theft. Now, the way we would solve this is would have an access control mechanism. And this would have access to the database based on the user roles and permissions, while encryption ensures that data is securely stored and transmitted into an encrypted form. Now, the last problem we'd face is data loss risk. Data loss can result from a system failure, human error, or malicious activities such as viruses. And the solution to this would be to have a backup and a recovery mechanism. This involves backing up data to prevent loss. And every company should have that. Now, what we'll be covering next are the common features of commercial database management. Now, indexing is one of those features, and this speeds up data retrieval operations by creating structure for quick lookups. The next feature would be SQL support. This provides standardized language for querying management relation databases. The next feature is data encryption. This protects sensitive information from unauthorized access or breaches. The next one would be backup and recovery. Safeguards data against loss and allows system restoration in case of failure. Now we'll be discussing the different types of data management systems. And now I can't cover everything, but I will go over a few primary ones. The first primary one is rational database management system, which we used within this project. This involves, how to explain it is, it basically involves tables and rows, columns, and it stores data in that structure. Now, NoSQL is unstructured and it's very flexible. And that's the second database management system type. And the last one that I'll be mentioning is the object-oriented database. Now, within this project, we used SQLite version 3. And it's very easy to use. Within this project, I had a very easy time using that. And it's been easy it helps, it's basically so easy when you're trying to manage your data. I had very minimal struggles that I faced while using it, and it's not very complex compared to other data based management systems. And now I will be showing you the design and structure of the database that we used, and showing you sort of how we code and incorporated this, and you'd have a visual understanding of it and seeing how we incorporate that into our project. So I'll be moving on to GitLab to demonstrate that. Just waiting for it to load. Now, you basically have our imports, and we have our world DB class. This basically creates the database. It's the database itself. That's what it's responsible for. It creates the table. So as you can see, as I'll be showing you now, we do have the table. Just give it a second. Okay, this is our file, but let me show you. So when you go down, you see that JHB37, the table, has been created. And there is data stored on this database. The database has been created. Now I'm going to go back to the source code so that we can see how I went about creating this database. Okay, so as I explained before, this is responsible. This world DB class is responsible for that. And now as we move onwards, we have a try and catch, which in case the database doesn't work, you would receive a something went wrong message. And then we create the two tables. The first table is world, the second table is obstacles. Now the world table inserts the necessary values in order to store the world. So it's connected to the different modules, in our code, and it takes information from that and then it inserts that into the table. So when a user has established a world, the information of that world will be stored, and this is the piece of code that is responsible for that. The method insert into world is responsible for that. Now, insert into obstacle is responsible for inserting all the tables, all the obstacles into the table. And it has connectivity within our code and connects when the user has an obstacle, will save those obstacles, and then that will reflect into the table obstacles. And the method forget the names. So now we don't want to store, we want to check if the world has already been stored, right? And we want to get all the names for that world. So that method is responsible for that. And yes, that's our database. Thank you very much, and we'll be moving on to the next section.
evaluating test execution and database verification in software testing. Now we know that JUnit is a popular testing framework for Java. It provides annotations, assertion, and test runners to support the development of unit tests, which are small isolated tests designed to ensure that individual components of a software application function correctly. JUnit helps developers identify and fix bugs early in the development process, promoting better code quality and reliability. It is widely used in the Java ecosystem and is integrated into many build tools and continuous integration systems. Now, with regards to our test plan and robot worlds, our objective was to verify application logic, database interactions, and to ensure that circuit communication met requirements. Now, with our test environment, we utilized Java, JUnit, Maven, in-memory database, and circuit setup. Now, with continuous integration, the pipeline was implemented in GitLab, which executes on every commit. To demonstrate the use of input data as specified in the test plan during the testing, I will not be using valid launch tests. This test to be specific. Now, this test method is designed to verify that the server responds correctly to an invalid launch command. Here's a breakdown of what each part of the test is doing. This test tag indicates that this is a test method that should be executed by the testing framework, which is JUnit and Maven. The method name suggests that this is checking that an invalid launch command fails as expected. Now, with the given statement, this sets up the precondition for the test. It ensures that the test only proceeds if the server client is connected to the server. Asset true checks that server client is connected and returns true. Now, with the when statement, this is the action being tested. It constructs an invalid JSON request where the command field is misspelled as LUANCH instead of launch. The send request method is used to send this request to the server and captures the server's response. Now, with the then statement, this checks the expected outcome. Asset not null ensures that the result field is present in the response. Asset equals checks that the result has the value error, indicating that the server recognized the command and returned an error. Now, for further validation, these assertions verify that the error response contains a specific message. Asset not null ensures that there is data field in the response. Now, this asset not null ensures that the data field contains a message field. For further validation, these assertions verify that the response contains a specific message. Asset not null ensures that there is a data field in the response. Asset not null, the second one, ensures that the data field contains a message field. Asset true checks that the message field contains the text unsupported command, confirming that the server is correctly identifying and reporting the unsupported command. Now, in summary, the test verifies that the server properly handles an invalid command by ensuring it's connected to the server, send a request with an intentional typo in the command, checking that the server responds with an error and specific error message indicating that the comment is unsupported. Yeah. With this being said, I can also note that we as a team did not have any deviations from the test plan and everything worked as expected. We will now run this test using our Maven. All the text in totality actually. In total, 40 tests were ran and there were no failures or errors. As a team, we managed to cover all the necessary tests and procedures accurately and thoroughly, showing effective use of tool properties, execution, and alignment with our standards for documentation and reporting. This alignment of our system frameworks and that the application this alignment affirms our system framework's effectiveness and that application reliability, giving us confidence in our development process and the quality of. And now, to showcase the elimination of errors identified through the testing of database access using SQL, I'll show that before each test is run, we have a setup, and after each test is run, we have a tear down. In the setup, a table is created, and in tear down, the tables are dropped. And how we do all of this is in the code itself. We have code for creating the tables. We are inserting into the world and also inserting objects into the world, obstacles as well. And we have a function for getting all the world names. To verify through testing that the database access performs according to requirements, we can run all of the tests concurrently to see whether they pass or not. And yes, the tests all pass. Now, to demonstrate and provide the records for all the tests executed during the testing of the computer program, you can simply head on down to the directory that contains reports of all the tests that were run, which we all found here. Fortunately, our team had no variations and all the tests ran according to the test plan. All the recorded results can be reproduced by simply going down into this folder where all the reports are saved, and you can simply access them there. And yes, a developer can access those results while.
And now we have section F, which is overview of documentation consistency and design adherence. So, as you have seen earlier in the presentation, my group members talked about the different kinds of documentations and practices that we had integrated into our system so that it is easier for the consistency and for it to be readable and all of that. So slide 1 is talking about structuring and reviewing documentation. So we had a specific way of structuring the documentation that we needed for our Brownfields module. We started with the README. Well, we just structured the README so that we know which guides and rules to follow. We have an instructions manual where it shows the user, which is someone that's going to be using our system. It shows them how to actually install our program. It shows them how to run our tests. It basically gives them an instruction from installing all the way to how to fix an error if you were ever to find yourself having problems. Our last point is creating documentation according to design content. So we had an overview of the Brownfield module in our curriculum, and that is basically what just helped us create our documentation and figure out how to do everything else. This is our instructions manual. So it shows you the commands to start the reference server. It shows you the commands to run the tests. It shows you how to launch the actual application, which is our Brownfields Robot World. It shows you the packages. It shows you how to package the projects that you use. Yes, and then so the instructions manual just basically tells you about our port, which reference server, which port our reference server is running on, and just basically what kind of server that we're using, the acceptance tests that we have, and how to run and see where they are. That concludes our Brownfield module presentation. Thank you very much for listening. See you soon.